This AWS course about data analytics. Our learning objective is to provide you with the information you need to take your initial steps into your data analytics journey by exploring the basics on that matter. If you don't know what exactly data analytics is and how organizations are using it to leverage more efficient solutions, then this course is for you. My name is Rafael Lopez, but you can call me Ref. I am from Brazil and I work with AWS training and certification for 6 years. I created this course where I will teach you the knowledge needed to create a basic data analytics solution out of log files. The plan to achieve that is to understand the basics of some of the most popular AWS services involved on doing data analysis. So I will talk about Amazon S3, Amazon Athena, and Amazon QuickSight. I will also talk about descriptive, diagnostic, predictive, and prescriptive data analysis types, mostly focusing on the descriptive analysis, which focus on exploring what happened. Ready to get started? I am, so come with me to start your journey about learning data analytics in the AWS cloud. Hello! If you are here, you probably have an interest in data analytics, and that's great. So let me start sharing with you the value proposition of what data analytics is. The first thing we need to think about when talking about data analytics is how to use the collected data to produce information that would be useful for future business needs. Those are called insights. Sometimes, this journey of generating insights out of data can be big and complex, involving the use of machine learning, or sometimes it can be quick and simple if the dataset is ready and you just want to perform descriptive data analysis. That being said, data analytics is the science of handling data collected by computer systems in order to generate the insights that will improve decision-making with facts based on data. Nowadays, data analytics is widely used for e-commerce and social media, but the knowledge can and should be applied into information security, logistics, factory operations, Internet of Things, and much more. There are 4 main types of data analytics, which in order of complexity are listed as descriptive, diagnostic, predictive, and prescriptive. Let me talk a bit regarding each one of those. I will spend a bit more time on the descriptive analytics because in this introductory course, this is what I will be mostly covering. Descriptive analysis is a data analysis type that is mainly used to give you information regarding what happened. It is intended to allow you to use data collected by a system in order to help you identify what was wrong, what could be improved, or which metric is not reporting as it should. As this type of data analysis is widely used to summarize large datasets in order to describe outcomes to stakeholders, think about descriptive analysis as something that just reports what's going on and nothing more. The most relevant metrics informed by those systems are mostly known as KPIs, or Key Performance Indicators. Identifying what happened can be extremely important for some market verticals, and sometimes are enough to satisfy the needs for further investigation into an issue. Let me give you an example on how descriptive data analysis can be useful in terms of identifying the correct KPIs to keep stakeholders aware on taking data-driven decisions to fix potential issues. Imagine an e-commerce website where you collect metrics regarding the time required for a payment to be processed. In this website, you are using an external payment gateway to complete the purchases. So every time a customer buys something in your website, the customer is redirected to that payment gateway and you have a confirmation that the customer had paid when he or she did so. A relevant set of KPIs for doing an effective descriptive analysis in this case could be metrics regarding the time required to complete the transaction, number of completed transactions, and number of cancelled transactions. Now, if you see a spike on both number of cancelled transactions and time required to complete the transaction, that may be a good indicator that those transactions are being cancelled because they are taking too long. It may be a good indicator that those KPIs might be related to each other, which could help systems administrators and business owners to start troubleshooting a potential issue that may be impacting on sales. The very same concept applies within the time to complete the transactions. If you have something that drills down into that metric by separating each step within the transaction time, you would have even more granular information to pinpoint the right place to solve the issue. The last thing you want is to be informed about system malfunctions via social media feeds or customer inputs. In this case, monitoring is key, and we used a very simple set of metrics in order to start troubleshooting a business-related issue. In a nutshell, descriptive data analysis is a concept that informs you what's going on. You can also do descriptive data analysis if you have data regarding user activity, social media feeds, Internet of Things, or system security logs. As I said, the use case can vary a lot, but one thing is for sure. Once you have the knowledge on how to perform descriptive data analysis, you can and should use that same knowledge to work with different datasets. Great! Now you have a solid fundamentals regarding what is descriptive data analysis. What about the other three? Well, remember in our example that you had the metrics regarding the transaction time and number of failed transactions? In that case, you were the one responsible for having the insight, for having the idea to correlate those two metrics together in order to identify the issue. The system did not connect them together and gave you a consolidated or a projected metric called probability of issue with the payment gateway. It is very common nowadays to have hundreds or even thousands of those metrics in systems, and diagnostic analysis helps by going over the scope of just informing, but diagnosing by further investigating and correlating those KPIs in order to give you suggestions on where the issue could potentially be. I like to refer to diagnostic analysis as a set of actions a system can do to help stakeholders understanding why something happened. The word you need to remember here is why. Our third type of data analysis is the predictive analysis. Predictive data analysis involves more complexity because, as the name suggests, it predicts what is likely to happen in the future based on data from the past, or based on doing a data crossover between multiple datasets and sources. In a nutshell, it kinda tries to predict the future based on actions from the past. The use of neural networks, regression, and decision trees are very common on diagnostic analysis, and we will be covering that in another course. Now, last but not least, prescriptive analysis, which is basically a sum of all the previous. Prescriptive analysis can go ahead and suggest stakeholders what are the most data-driven decisions that needs to be taken based on past events and outcomes. Prescriptive analysis highly relies on machine learning strategies in order to find patterns and their corresponding remediations by looking and crossing large datasets. Regardless of the type you decide to learn and apply, data analysis exists at the intersection of using information technology, statistics, and domain knowledge, like social media, business, or industry verticals. In this course, we will be focusing on how to use AWS services to perform descriptive analysis about what's going on with an AWS account by using security logs. If you got interested and want to dive deeper, check out the course notes for this video. Now that you understood the different types of data analysis, let's continue the journey by exploring some more examples on where data analysis is present in your life right now. Now that you know the difference between the different types of data analysis, let me show you some examples on how data analytics is very likely to be present right now in your life, both as a consumer and perhaps professionally. Data analytics is widely present in many verticals today, such as gaming, social media feeds, e-commerce, online stores, website statistics, also known as click streaming, recommendation engines, Internet of Things or IoT, log processing, and much more. Let me give you a couple of examples on where data analytics is valuable in some of those scenarios, so you grasp what is the exact purpose of data analytics in these contexts. Let's say you like to play computer games, like me. Who doesn't, right? So if you like to play games either in your phone, your computer, or in a game console, you may be familiar with the checkbox you may need to check before start play. That checkbox usually says something like send anonymous data statistics for game developers to improve gaming experience or such. What this does is basically allowing collecting information regarding the way you play the game in order to detect potential crashes, design failures, and other data. It is clear in this case that real-life data such as you playing a game is being transformed into information that helps developers to circumvent potential issues and enhance the gaming experience. That is exactly why data analytics exists and why it is so relevant for the modern world. You may ask, why is this a thing nowadays? I've been playing games since childhood, and that was not the case. Games were sold on cartridges, we used it to buy and play it, right? Well, yes, but if you think with me, those games were not that complex as the games we have today. And that's what I want to conclude. Analytics helps people develop insights, and those insights help them to deal with complex problem solving. No matter if it is regarding gaming, stock market, real estate data, traffic information, fashion, computer systems, web server, or security logs, data analytics help to provide answers to complex scenarios. With storage prices going down day after day, companies often collect data that may currently not have a use for. However, if a question arises tomorrow, the answer can be in the data they had previously collected. The world nowadays is becoming more complex than it was 10 years ago, and having the help of computer systems is instrumental for two main reasons: scalability and data-driven decision making. Another major part of data analysis is log analytics. Let me dig a little deeper into this one because that is where I will mainly focus during this course, specifically regarding security logs. When we talk about log analysis, we're usually talking about the information produced by computer systems based on events. That event can be an HTTP request made to a web page, user login information, API calls, or any other type of requests. API is the acronym for Application Programming Interface, which is basically a computing interface which defines interactions between multiple software intermediaries. It defines the kinds of calls or requests that can be made, how to make them, the data formats that should be used, the conventions to follow, etc. And for the data analytics standpoint, it is very common to log all those activities somewhere. A classic example of data analytics is using web server logs to extract insights about visitors in a website. Let's say every request made to an HTTP server is logged into files in a file system. Those are mostly called access logs. If you have one new line added to the access log per every visit in your website, you can say that the number of lines in this log is equivalent to the number of requests that was served by the web server. If you just have one server and a small website with a couple of visits per minute, you can use some basic tools like text editors to parse those files and extract what you're looking for. But if you want to do something slightly more useful than just summing up lines in a log file, the usage of a data analysis tool is key. We encourage using data analysis tools everywhere, but we need professional ones that handles scale when we want to do log aggregation and visualization. Imagine you have tens of web servers attending thousands of users per second. You can estimate that each log file on each server will be filled up pretty quick. So you need to have all that data concentrated somewhere. In addition, you may need to have a way to visualize that data in a line chart, which could easily help you identifying spikes, also called deviations or outliers. Another big use of data analysis nowadays is data security. If you have systems producing security logs in a way you can quickly get into in order to extract analytics, you are in clear advantage if you need to pinpoint when a request was made, by whom, from when, from where, and what was the system's response to that request. If you reach into the level of doing predictive analysis on top of this data, you can even reach a state where you automatically block bad requests to computer systems before they occur, or creating a self-healing architecture that starts building a failover environment when a current environment is presenting degradation. That can be achieved with the help of infrastructure automation tools in the cloud. There is an AWS service called AWS CloudTrail, which logs API activity made to an AWS account, and another AWS service called Amazon S3, which is a storage service. Let me briefly talk about them. This is what CloudTrail stores every time you or someone logs into your AWS account by using the AWS Management Console. That is stored in Amazon S3 and contains information such as who made the request, from which IP address, what was the request for, what was the answer to that request, and some other useful compliance information that can quickly turn into evidence if needed. Because of that nature, CloudTrail is a service that enables infrastructure governance, operational auditing, and risk auditing for your AWS account. But if you need to dig into CloudTrail text data every time, it may be something hard to achieve. So learning data analytics helps a lot to unleash what you can do with all this compliance data. If you had data visualization tools on information produced by CloudTrail, you can have security dashboards containing graphics and alerts of unusual activities. If you suddenly start seeing logs of login failures activities, it may be because someone is trying to log into your AWS account or because you changed the password and forgot it. I usually say that data security analytics is not good only for compliance reports, but also very useful for troubleshooting. If you apply that concept to firewall packets, networking activity, load balancer and server logs, and other kind of infrastructure topics, you can easily identify outliers and turn yourself into a quick problem solver. For the sake of simplicity and introduction to the subject, in this course I'll be talking about getting insights out of CloudTrail data. So I'll revisit CloudTrail again and build an analytics solution out of it. But always think about what else could you be using data analytics for and how it helps you on getting stronger insights about what's going on, no matter if it is regarding security, product improvement, better customers experience, or any other part of the data analysis spectrum. Since the sky is the limit, in the next video I will be talking about why doing all this in the cloud gives you some serious advantage and how it helps on enabling data analytics everywhere, anytime, for everyone. You may already know that the cloud is more flexible, scalable, secure, distributed, and resilient. But I want to give a more data-related approach in terms of why cloud computing is relevant for data analytics. In this section, I will explain why the cloud is the best way to perform data analytics nowadays and why it has been solid for operating big data workloads. So let's get started. Before we start talking about cloud, allow me to go back in time, maybe a decade, and tell you a brief story. After going back in time, it will be natural for you to understand why everybody loves doing data analytics in the cloud. Ready for the journey? Get your beverage of choice and buckle up. Years ago, the most common approach for companies to have compute infrastructure, big data included, was to buy servers and install them into data centers. This is usually called a colocation, or colo. The thing is, servers utilized for data operations are not cheap, because they need lots of storage, consume lots of electricity, and requires careful maintenance regarding the data durability. Hence, entire dedicated infrastructure teams, and trust me, I've been one of those infrastructure analysts working with data centers. It is expensive and overwhelming. With that scenario, only big companies were able to work with big data, and consequently, data analytics was not popular. It was very common for those servers to have a RAID storage controller that replicates data across the disks, increasing the cost and maintenance care even more. In the early 2000s, big data operations were closely related to the underlying hardware, such as mainframes and server clusters. Although this was extremely profitable for the ones selling hardware, it was expensive and not flexible for the consumers. Then, something fantastic started to happen, and the name of this fantastic thing is Apache Hadoop. Mostly, what Hadoop does is replacing all that fancy hardware by software installed in the operating systems. Yeah, that's right. With the help of Hadoop and computing frameworks, Data could be distributed and replicated across multiple servers by using distributed systems and eliminating the need of those expensive data replication hardware to start working with big data. All you needed was efficient network equipment, and the data were synchronized over the network to other servers. By embracing failures instead of trying to avoid them, Hadoop helped reducing hardware complexity, and when you reduce hardware complexity, you reduce cost. And by reducing cost, you start to democratize big data because smaller companies could start leveraging it as well. Welcome to the big data boom. I brought up Hadoop originally because Hadoop is the most popular open source big data ecosystem. There are others, and what I want to highlight here is the concept and not specific frameworks or vendors. The thing is, by baselining hardware to a basic level and applying all big data concepts to software such as data replication, we can start thinking about running big data operations on providers that are capable to provide virtual machines with storage and a network card attached. We can start thinking about using the cloud to build entire data lakes, data warehousings, and data analytics solutions. Since then, cloud computing has emerged as an attractive alternative because it is exactly what it does. You can get virtual machines, install the software that will handle the data replication, distributed file systems, and entire big data ecosystems, and be happy without having to spend lots of money in hardware. The advantage is that cloud does not stop there. Many cloud providers, such as Amazon Web Services, started to see that customers were spinning up virtual machines to install big data tools and frameworks, and then based on that, Amazon started to create offerings with everything already installed, configured, and ready to use. That's why you have AWS services such as Amazon EMR, Amazon S3, Amazon RDS, Amazon Athena, and many others. Those are what we call managed services. All those are AWS services that operate in the data scope. In a later lesson, I will talk more about some services we will need to build our basic data analytics solution. Another big advantage of running data analytics in the cloud is the ability to stop paying for infrastructure resources when you don't need them anymore. This is very common in the data analytics because due to the nature of big data operations, you may need to run reports once in a while, and you can easily do that in the cloud by spinning up server or services, using them, getting the report you need, saving that, and turning off everything. In addition, you can temporarily spin more servers to speed up your jobs and turn off when you're done. And since you mostly pay per time and resource needed, 10 servers running for 1 hour tends to have the same price of 1 server running for 10 hours. Basically, with the cloud, you are having access to hardware without having to concern with all the burden involved on doing data center operations. It is like the best of both worlds. Stay with me to learn more about AWS services I will use towards my descriptive data analysis solution using Amazon S3, CloudTrail, Amazon Athena, and QuickSight. In this lesson, I will be talking about the basics on Amazon S3, Amazon Athena, and Amazon QuickSight, because those are the 3 services our data analytics solution will be built on. So before I start talking about the solution itself, I want to quickly introduce you to what those services do. S3 means Simple Storage Service, or SSS, or S3. As the name suggests, it is the most simple and popular AWS service for storage. We all love S3 for many reasons, being the 3 most relevant ones. First, it replicates data by default across multiple facilities, providing solid data durability, which means that chances of data being lost is reduced a lot. Second, it charges per usage, so the pricing goes exactly according to your needs. No more, no less than what you need. And third, it is deeply integrated with other AWS services. So if you have any other AWS service that needs to store data somewhere, S3 is the very first candidate to be integrated with that service. For example, if you are using AWS Elastic Load Balancer or ELBs to balance traffic to your website front end, ELB can save the access logs into an S3 bucket. You've seen me saying S3 bucket. In the S3 nomenclature, buckets are the basic storage units that you put your data into. There is some basic vocabulary, which I can quickly explain. S3 is the service, buckets are the logical storage unit, objects are the data you add into a bucket. A bucket policy is the permission mechanism applied to a bucket, which defines who can and who cannot interact with the data inside it. In addition, S3 allows you to configure a storage class on the object level, also known as storage temperature, such as more or less accessed. That changes the price you pay per gigabyte stored, and you can save some money by moving less frequently accessed objects to a colder storage class. One bucket can have multiple objects, and the configuration of storage classes are on the object level. So you don't need to create multiple buckets or move objects around if you want different storage classes in your buckets. I put more information regarding storage classes in the course notes. Don't forget to take a look. What you need to know in order to build our analytics solution for this course is just that S3 is a secure and private place to store your data with redundancy and high availability. S3 is really simple. You create a bucket, add files to it, and read files from it. In S3 verbiage, those files are called objects, but I may call them files along this course just for simplicity. Now, let's say you have a CSV file, or comma-separated values. You may already be familiar with that file format, but imagine you want to import that file into a system in order to perform SQL or SQL queries against and extract insights. Imagine you have one, or better, thousands of files like this one you were seeing. This file contains information about taxi rides in New York City. It is a CSV file containing information regarding every ride, where each line represents a ride. I got this file from the AWS datasets page. You can get more information from the AWS datasets by reading the course notes. If you want to do a SQL query based on the information of this file, such as select average of the cost of the taxi rides during the month of January, you can do a SQL query. And if you want to do that with SQL, you basically have two options. Option 1, create a relational database server, such as MySQL or SQL Server, import that data into a SQL table, and perform the query regularly. Which, although could do the job, it wouldn't scale very well, and there is a better way of doing it, which is option 2. So option 2, import this data into Amazon S3 and use Amazon Athena to make that query without the need of creating database servers and having Amazon Athena performing the processing and scalability under the hood. That's right. Amazon Athena gives you the ability of doing SQL queries on top of files stored in S3, with no databases to configure, no servers to manage, and no database engine configurations to be done. That is what we call a serverless solution because there are no servers involved. You just create an Amazon Athena table, point that table to the bucket location, and you are ready to query against it. It is pretty simple and allow you to have an effective data processing tool out of the box. Athena also provides high availability by default and don't store your data, it just makes the queries. The best thing is that the data is primarily stored in Amazon S3 and not in Athena tables themselves, allowing you to centralize all your data into S3, which we already know is highly durable. Well, now that you have a way to store files and query them, a missing component for a complete data analytics solution is a way to visualize the results of those Athena queries. Because Athena would give you text as the query result, but let's say you want to have a pie chart. Introducing Amazon QuickSight. Amazon QuickSight is a service that provides you dashboards and other ways to visualize and analyze your data. Let's say that you do an Athena query that results of a sum of the number of taxi rides per month. If you want that plotted in a pie chart, Amazon QuickSight does it. Do you want that plotted in a graph chart to follow up month by month? Done. QuickSight can also do that. What about day by day? Simple. Just ask QuickSight to perform a different Amazon Athena query grouping by day instead of month. You can actually do that by clicking around in QuickSight's web interface, as you will see in the demo I'm going to do in the next video. Those services are all integrated with each other and are the basic construction for many data analytics solutions: S3 to store, Athena to process, and QuickSight to visualize. Since they are all AWS services, the integration between them is seamlessly done, being very easy to start and to work with. I hope you are getting excited as much as I am about creating a simple data analytics solution. Ready to proceed? My idea is to explore AWS CloudTrail data that gets added automatically to S3, then dive deeper on Amazon QuickSight in order to create some cool visualizations. Let's do it.